All right, here we're looking at section number 2 in chapter 1. So our learning targets for today, first we're going to graph equations by plotting points. Then we're going to be looking at intercepts from a graph, and then finding intercepts from an equation. Then we're going to look in test equations for symmetry with respect to the x-axis, the y-axis, and the origin. And we're going to see why that's important. And then 5, we're going to know how to graph some key equations, and we'll get to those key equations in a little bit. But these are ones that we're going to continue to focus on throughout this year. So first thing, we're going to graph some equations by plotting points. So example number 1 in your book is we're going to first determine whether a point is actually on my graph of the equation. So here I'm given my equation 2x minus y equals 6. And it doesn't have to be written any certain way. We can look at any equation given any way. And we're asked to determine if this point here, 2, 3, is in this equation, like lies on the graph of that equation. Because remember, the graph of an equation is all points that fit the equation. That's what the graph makes up. So I want to see if x equals 2 and y equals 3 will make a true statement. So all I do is I plug in a 2 for my x and a 3 for my y, and then I simplify and solve, and I see that this equals 1. Well, I see given my equation it's supposed to equal 6, so it is not on the graph. So now let's try point B. 2, -2. So again, I just plug those values in and simplify and solve. And since I ended up with 6, which is what I have in my equation, I can say that yes, this is on my graph. So example number 2, we're going to be graphing an equation by plotting these points. So I have my equation y equals 2x plus 5. And I should be able to recognize that this is a linear equation because my x does not have an exponent. It is not in the denominator of a problem. It's just a simple linear equation. So the first thing I want to do is I figure out that this graph is all points that satisfy the equation. So I just assign some numbers to x. I just pick some numbers. So here in the book, the example, they picked 0, 1, -5, and 10. And really you can pick any numbers that work or that are easy for you to work with. So now I have my points. I substitute those in, find my y values, and I have my points that I can put on my graph. So now I can just plot those points that I'm given, and I see that yes, they do make a line. So example number 3, here's another equation that we're going to be plotting a lot. This is a quadratic, my parent quadratic, right? Because y equals x squared. And anytime I see that x squared, I know it's a quadratic equation. So again, I just pick some points, and then I plug those in and I plot those points. You should be able to just recognize this one right off the bat because we're going to use it a lot, and we have used it a lot. So here's our next learning target. We're going to be finding intercepts from a graph. So there are several points where we can look at. So I have a y-intercept, and that's where it crosses my y-axis. I also generally have x-intercepts, 1 or more, and that's where my graph touches the x-axis. So here's example 4. I'm asked to find all the intercepts from this graph. So first I want to find my y-intercept. So that's going to be anywhere my graph crosses the y-axis. So then I can find my x-intercepts and see anywhere that it crosses my x-axis. Those will be my points that I'm looking for. Okay. So my next learning target, find intercepts from an equation. Okay. So first we looked at graphs, and now we're looking at equations. So here's how I do this. To find my x-intercepts, I make y equals 0 in my equation and solve. To find the y-intercepts, I make x equals 0, and I solve and find those points. So here's my example number 5. So find the x-intercepts and the y-intercepts of this graph, y equals x squared minus 4. Then graph it by plotting points. First, you need to notice that this is, again, a quadratic because I have that x squared term. So to find my x-intercepts, I set y equal to 0. Okay? And then I can simplify and solve. Since I know that this is a quadratic, I look and I factor it. This would be the difference of two squares because I know the square root of x squared and I know the square root of 4. And I'm subtracting, so the difference of two squares factors this out. Then I use my zero product property, which sets each piece equal to 0, and then I solve for both. So I know I have two x-intercepts here at a -2 and a +2. So now I want to find the y-intercept. So I make x 0, and I substitute that in, and I get my y-intercept of -4. So now I see that my y-intercept is that -4. Since x squared is greater than 0 for everything, because I can square a negative number and it becomes positive, so I also know that y has to be greater than -4 for this equation. Okay, so let's look at the graph. So I pick some points, and I know my y-intercept, and I know my two x-intercepts. So now I can just pick a couple points in between. So I pick a point in between my x and y, and a point in between my x and y, and then a point on each side of my x-axis. So then I can plot those and graph it. So our next learning target. So we're going to test an equation for symmetry with respect to the x-axis, the y-axis, and the origin. Now remember that symmetry is where I can fold it like a piece of paper or a mirror, and it's exactly the same. So my graph is symmetric with respect to the x-axis, and remember my x-axis goes this way, for every point xy, that the point x negative y is also on the graph. So this kind of makes sense because if I have, here's my x-axis, if I have x comma y, right, that goes right there, I know that if I have x negative y, that's symmetric. It's the same distance from the x-axis. Okay, so that's how I can keep that in track. So here's a graph that shows symmetry with respect to the x-axis. I can see that each point is exactly the same distance from the x-axis as its corresponding point in the other colored graph. So example number 6, let's look at these points. So if a graph is symmetric with respect to the x-axis and the point 3, 2 is on the graph, then the point 3, negative 2 is also on the graph. So that's just kind of showing and telling us exactly what we were just looking at. So now I could also graph that if I needed to, and just kind of see what we're looking at. So now we're looking at respect to our y-axis, right? And that's going up and down. Okay. Seeing if we're symmetric around this. So just like our last definition, here I have x comma y. So I know in order to be symmetric across my y-axis, it has to be over here. So I'm going to have that negative x comma y. So if this is true for every point, then my graph is symmetric across the y-axis. So you'll see here, this example, these 2 points are the same distance, and these 2 points are the same distance. So I know that this does show symmetry with across my y-axis. Okay. So again, here we're just showing that these 2 points, so I've got 5, 8 and negative 5, 8, those would be symmetric across the y-axis. Okay. So now we're looking around the origin. Now, so remember the origin is the point very in the center of my axes. So to see something that's symmetric across the origin, if I have my point here, which is x comma y, my point that is now symmetric is going to be down in this third quadrant, which would be negative x comma negative y. So I have to flip the sign of both x and y values. Okay, as we see here, I have a positive xy, here I have a negative x and negative y. Okay, so here's my example. I've got the points 4, 2, so I know that the points negative 4, negative 2 is also on my graph if it's symmetric about my origin. Okay, so how I can test for this, whether I have a graph or I have an equation. So to find if it's symmetric around the x-axis, I replace y with a negative y in my equation and simplify. To find if it's symmetric around the y-axis, I replace my x with a negative x. And if I want to look at the origin, I replace both x and y with the negative x and negative y. So let's look at what this actually looks like. So here's my equation, y equals 4x squared divided by x squared plus 1. And I'm testing this for symmetry. So here we're first testing if we're symmetric about the x-axis. And to do that, I replace y with a negative y, which is done right here. So I see that this is not exactly the same thing as here, so I know that it is not symmetric across the x-axis. So now let's look at the y-axis. To do that, I replace all of my x values with a negative x, and then simplify. So here I've replaced, and I know that when I square a negative, it becomes positive, so I see that my equations are exactly the same. So it is symmetric with respect to the y-axis. So now let's test for the origin. So now I have to replace both x and y. So I go through and I simplify, and to get y by itself, I multiply both sides by negative 1, and I see that they're not exactly the same, so I know that it is not symmetric about the origin. So here's the actual graph of this equation we were just looking at. Now, as you can see, I could fold it along my y-axis, and it would look exactly the same. It would fit on itself. So I know that it is, in fact, symmetric about that axis. Okay. So now here we're looking at some of those key equations that I talked about. and we're going to be graphing them, and we can either graph them by plotting points or using our graphing calculator or even Desmos. So the first one we're going to be graphing is y equals a negative x cubed. We can also just graph a positive x cubed, and you'll see the differences there. So first we want to find intercepts, look for symmetry, and then plot some points. Those are going to be the steps we're going to follow here. So first I find my intercepts. So I plug in my x equals 0 and solve, and I plug in y equals 0 and solve. So I find out I only have one intercept, which is the origin. Now I can test for symmetry. I want to see what this kind of looks like. So about the x-axis, I replaced my y with a negative y, and I see that it is not symmetric because I do not end up with the same exact thing. Now we check the y-axis. I replace my x with a negative x. These are not the same thing, so I know it's not symmetric. Now let's check the origin. I replace both x and y with negative x and negative y, and simplify, so I see that this one is symmetric about the origin. Okay, so now I can find some points and plug them in. Well, I know this one already because this was my intercept that I've already found. So now I just pick a couple extra points and plot those. Okay, so here's kind of the original graph. And I don't have to pick all of these points because I know it is symmetric about the origin. I only have to pick a few points either on the left or the right of my intercept, and I know exactly where it will fall. So here's my next equation, right? This is x equals y squared. So we've looked a lot at y equals x squared, so now we're just switching it around here. So first we have to graph this equation by finding the intercepts and checking for symmetry, and then I want to graph it. Okay, so when I'm checking for my intercepts, I see that there's only one, and it's at 0, 0, which is my origin. Once I do the symmetry tests, I see that it is symmetric about the x-axis. So then I just plot some points, and here I don't have to pick them all because I know that I'm symmetric here. Okay. So now part B, I'm restricting this so that y is greater than or equal to 0. So now I can get rid of the entire bottom half of my equation. And sometimes I want to do that if I'm trying to make functions, because this one is not a function, but this second one is, and we'll talk much more about this in Chapter 2. Okay, so you can see this on a graphing calculator as well. So here I've got my positive x square root of x, and I've got my negative square root of x. So I can get rid of one or the other if I limit my range. So here's another family of functions that we're going to be looking at pretty often. It's 1 divided by x. We haven't really looked much at when x is in the denominator. So first, again, I want to find my intercepts and check for any symmetry. So first, I find intercepts. If we have x equals 0, we have a 0 in the denominator, so I know that that's not going to actually happen. So then I let y equal 0, so I know that that has no solution, so there's no intercepts. Okay, so I know that this graph does not cross or touch any of my axes. Okay, so now I can check for symmetry by replacing my y's and my x's by negatives and seeing where it's symmetric. So I see that it is not symmetric over the x-axis, it is not symmetric over the y-axis, but it is symmetric over the origin. So now I set up a table, right? I just pick some points for my x, I plug them in, and I simplify. So here are the points that I picked for x. Right in here, we pick some of these points because they're fairly easy to graph, right? So here's where you can pick any values of x, and you can go from there. Okay, so I pick my x value, I plug it in, and I end up with my point that I can plot. And here again, I see that I'm not touching any of my axes, and I am symmetric about the origin. Okay, so here's back to review of our learning targets. First, we were graphing equations by plotting points. Then we looked at a graph to find the intercepts, the x and y intercepts. Then I figured out how I could find those intercepts from an equation by setting x equal to 0 and y equal to 0 and solving. Then we looked at how to test for symmetry over the x-axis, the y-axis, and the origin. And then we looked at some key equations that we're going to continue to use. So that is all of our information for section 1.2.